Lesson 15.1, Task 3. Multiply monomials in two or more variables. When you multiply two monomials, the product is always another monomial. When multiplying monomials that have two or more variables, first group numbers and like variables. Then you can use the product of powers to simplify the monomial. Though the property applies to all rational exponents, recall that monomials have only integer exponents. Alright, so remember this is a review, product of powers. When you have the same base and you're multiplying, you add your exponents. This is one of the property of exponent rules. Alright, so same base, when you're multiplying, you add exponents, where a is a real number and m and n are rational numbers. So if I want to multiply the monomials, negative 2a squared b squared and negative 5a to the 7th b to the 1st, which property justifies grouping factors of the monomials in order to multiply? Alright, so that would be commutative and associative property. Basically means we can rearrange those and group the numbers together and then group the variables together. Alright, so it shows that they're going to regroup the negative 2 and negative 5 together. They're going to group the a's together and the b's together. Alright, so negative 2 times negative 5 is positive 10. Same base a's, I add my exponent and get 9. Same base with my b's, I add my exponents. Remember, there's a placeholder of 1 here. So 2 and 1 give me b to the 3rd. Which property justifies rewriting this as this? So you can see what they've done. They've taken the same base and add the exponents. So that's the product of powers property. Alright, so that's all for task 3. If you have any questions, let me know. Lesson 15.1, task 4. Find monomials raised to powers. You will use the power of product property and the power of power property to raise a monomial to a power. Alright, so the power of a product property, product means multiplication, remember. So you've got parentheses, AB, raised to the m power. So you're going to raise each thing inside of your parentheses to that power. So anytime you have a power of a product, it's going to equal a to the m, b to the m. Basically, anything inside the parentheses is raised to that power, where a and b are real numbers and m is a rational number. All right, so what is a power of a power? That's when you have two exponents. So you've got one base and a power raised to another power. In this case, you multiply exponents, where a is a real number and m and n are rational numbers. All right, so number 4 says find, and we've got a product raised to a power, so we've got 2x to the 4th, y to the 3rd squared. So that means everything inside this parentheses is going to be squared. So let's start with the 2. 2 squared is 4, and then we've got x to the 4th squared. So a power to a power, remember you multiply, so x to the 4th squared would be x to the 8th. And then y cubed squared would be y to the 6th. Again, when you have a power to a power, you multiply exponents. So it says, which property justifies writing 2x to the 4th y cubed squared as each thing squared? All right, so that is a power of products property. Okay, so it's a power of a product. Remember, product just means multiplication. Those things are multiplied and all raised to a power. Which property justifies rewriting 2 squared, x 4th squared, and y cubed squared as this? So what they're doing is taking a power to a power, and that means they multiply this. So that is a power of a power property. All right, that's all for task 4. If you have any questions, let me know. Lesson 15.1, task 5. Find the volume. You can use products of monomials to model the volume of three-dimensional figures. Home aquariums can be cylinders or rectangular prisms, as well as other shapes. Aquarium A and Aquarium B are shown. Aquarium A has a length times a width times a height. So we've got 2x, x, and x, all in inches. Aquarium B has a diameter of 2x, which means the radius would be x, and it has a height of 2x as well. It says find the volume of each aquarium. For aquarium A, use the formula of volume for a rectangular prism. That equation is volume equals length times width times height. So you can look at this one here and see that it's going to be 2x times x times x. So they've got 2x times x times x. So if you pull out the 2, then we have x times x times x. And again, remember, you can assume all of those have an exponent of 1. Same base, you add exponents, so 2x cubed is the volume of aquarium A, the rectangular prism. All right, it says complete the statements about the factors of the expression 2x, x, and x. The length of the aquarium is represented by the 2x. The width is represented by the first x here. And the height is represented by the next x there. All right, it says the volume of aquarium A is 2x cubed inches cubed. For aquarium B, use the formula for the volume of a cylinder. That formula is volume equals pi r squared times h. H is your height, r is your radius. All right, so volume of a cylinder, pi r squared h, which correctly describes the units used for the volumes of the aquarium. All right, the units are in inches. So it's going to be inches times inches times inches, and it would be cubic inches, because when you do it 3 times, it's to the third power. Anything to the third power is going to be cubic. All right, the volume of aquarium B is volume equals pi r squared h. Pi is part of the equation, so you keep it. Remember, it's approximately 3.14, but there is a button on your calculator that is pi. But right now, we're just going to leave this as pi. And then x squared times 2x. So we can rearrange this using commutative property and put the 2 first. And so pi times 2. And then that puts our x's together. Same base, we add exponents, so you get 2 pi x cubed. So the volume of aquarium B is 2 pi x cubed, and again, that's in inches cubed. And again, it's 3-dimensional. Volume is 3-dimensional, so it's going to be cubic. Complete the statements regarding the factors of the expression pi, 2x squared, and 2x. All right, so for aquarium B, the value of pi is part of the formula. The radius should be half of, maybe it's the whole thing. Okay, there's a line pointing here. I don't know if that's the whole diameter or the radius. Remember, diameter goes all the way across. Radius is just from the center to the edge. So it's pointing here, so I'm not sure. We'll go with it. All right, so the first 2x, so it's pi r squared h. So this should be my r squared, and the height is 2x as well. All right, which property justifies rewriting 2 pi x cubed? All right, so we're going from here to here. So that is our product of powers property. Remember, a power of a product is when something's in parentheses raised to a power. A power of a power is when you have an exponent raised to another exponent. The product of powers is when you have the same base multiplying, product means multiplying, and you add your exponents together. All right, so it says compare the volumes. The volumes of both aquariums are monomials in terms of x cubed. The coefficient of the monomial that represents the volume of aquarium B is 2, and the coefficient of the monomial that represents the volume of aquarium A is 2 pi. So the volume of aquarium B is pi times greater than the volume of aquarium A for any value of x. Aquarium B will always have the greater volume. All right, so if you look back up here and you see that this one's going to be 2 pi x cubed. All right, so that's the volume of aquarium B, 2 pi x cubed, inches cubed, and aquarium A is 2x cubed, inches cubed. So the only difference in aquarium A and aquarium B is that B is pi times bigger. So that's why it says that aquarium B is pi times greater than the volume of aquarium A. All right, so that's all for task 5. If you have any questions, let me know.